6. Okay? So here we are in our special right triangle introduction. So the purpose of this activity is to show you that there are some correlations between sides of what we in mathematics call special right triangles. And those triangles, first one that we're going to look at here is an isosceles right triangle where the two legs are the same size. So we have the hypotenuse, okay, and on each of these examples, 1, 2, and 3, the hypotenuse is a length of x. But this is called, again, an isosceles right triangle, if you want to jot that down up to the top side there. That correlation is that the legs are the same size, which forces, if you didn't know, there's a direct relationship between the angles and the sides. So if these two sides are the same length, these two opposite angles have to be the same size. And if we have a right triangle, the two angles that are left have to add to 90. And dividing that in half, it's forcing what we call a 45, 45, 90 triangle. Okay? 45, 45, 90 is our first special right triangle that there's always some cool, like little things that are always true. So I asked you to find the length of x. So you would use the Pythagorean theorem over and over and over again here to see that correlation. And I asked you to then, once you got your answer, to not write it as a decimal, but a exact answer. And I'm guessing most of you then on number 1 wrote that your answer was square root of 2. Yes? Okay? But did you notice that the length here was 1? Right? And on number 2, when we did simplest form, when you used your ladder method from square root of 8, you got 2 square root of 2. And for number 3, after we ladder, we get 3 square root of 2. Raise your hand if you saw the correlation between the number out front and the original side length. Okay? How many of you saw that here, like pretty quickly, or you went back and saw it after you got to question 6? Okay? All right, so moving on to 4, seeing this discovery here. Oops, calibration's off a smidge. Try to go full screen. Square root of 32 is reducing to 4 square root of 2. And 5 was reducing to 5 square root of 2 when we use our ladder method. Okay? So some of you could then maybe just look at and say, what does 6 need to end up as? Right? The side length is A. So to go from the leg to the hypotenuse, every single time it was what? Times square root of 2. When you were using the Pythagorean theorem, you would have had a squared plus a squared equals x squared. How many a squareds do we have on this side? 2. A squared equals x squared. We go to square root both sides. Remember the phrase here? I know some of you left your answer right here, but we can simplify this more, right? The square root of x squared is just x. The square root of a squared is a. You can bring the a out front, and your square root of 2 stays. So what that means is, on a 45, 45, 90, if I give you one piece, whether it's the hypotenuse or one leg, you can calculate the other 2 pieces. And we don't have to have at least, Pythagorean theorem, we have to have at least 2 sides to get the third. Special right triangles that we're investigating here is going to let us be able to find those other sides without using the Pythagorean theorem, meaning we're gonna start with one piece. So, multiplying by square root of 2 takes us from the leg to the hypotenuse. If I give you the hypotenuse, and you want to go backwards to the leg, what do you think you would do? Divide by the square root of 2. Okay? And so what we're going to do next is practice multiplying and dividing with square root of 2 and talking about how we work with, because we don't want to go in decimal form. So that's what we're going to get to next before the end of class, is just the ideas of how to work with these shortcuts they're eventually going to be called shortcuts, but how are we going to work with this? Okay, so let's look at the next problem. There's a lot of different ways in mathematics to find the correlation on what we would call a 30, 60, 90 triangle. So just like in example 11, this is what I want you to be able to look at. So the second special triangle is going to be called a 30, 60, 90. And you can get a 30, 60, 90 from starting with a equilateral triangle that we were just talking about. So if we go back to example 7, this whole entire large triangle was the equilateral triangle. If you didn't write that down, make sure you do so. And we know that the equilateral triangle has 3 equal sides, 3 equal angles. So when I drop in, again, this was called the altitude, or the height of the triangle. We measure height at 90 degrees. When you have an equilateral triangle, the altitude divides the triangle exactly in half. If I have a triangle that's not equilateral, sometimes dropping in the perpendicular is over here, like off to the side. And it doesn't always form 2 equal triangles. But on an equilateral triangle, it does. And so we know that this segment is congruent to this segment. That's why I put 1 and 1 there for you. Okay? Which, if that whole side then is 1 plus 1, this whole side is 2, which means x must be 2. Number 8, what's our answer? 4. Number 9. All right, so not as fancy as seeing the square roots reduce out front. Not as cool as 1 through 6, but still, we're seeing a connection here. So the length of x is 8. The length of x is? Okay. So what is the length of?
A plus b with 4.
So we're going from 5 to 10. What do we do to go up to here? It's what?
2a.
Times 2. So x is 2 times a. Okay? Make sure you wrote this correctly. I heard some of you say it opposite back here. X is going to be the value of a times 2. Now, a moment ago, I was talking about those 45, 90s, and I called those 2 sides, that the isosceles pieces, not the hypotenuse, the other 2 pieces, I called them legs. And those legs are the same size. So we're just going to say this is leg 1 and leg 2. On a 30, 60, 90, okay, we're going to still have our hypotenuse, but we're also then going to have, we still have 2 legs, but now we're going to categorize them as short leg and long leg, okay? And what we just figured out, A is going to be the short leg. It's going to look shorter. I'm going to draw these to scale, but we know it has to be shorter because it is opposite the 30-degree angle, right? And 60 is going to be across from the long leg. So I want you to write A, short leg, okay? And we know that to go from the short leg to the hypotenuse, it's always times 2, okay? And we know how to multiply by 2. And what do you think I would want you to do if I gave you the hypotenuse? You could find the short leg by dividing by 2. Again, I won't have to work with that today with you. But let's look at the last example here. $13, right? Is that where we're at? And I don't know if anyone saw that connection before. It was pretty self-explanatory. But we have 2 times 1, that's just 2. 2 times 2 is 4. When you were using the Pythagorean theorem to find x here in this section, I hope you didn't leave that in multiplication form, okay? So on 13, when we use the Pythagorean theorem here, we would have had 2 squared is equal to 1 squared plus x squared, okay? And if you're curious what all these little acronyms are, obviously hypotenuse is going to be abbreviated HYP. SL is going to be short leg, and XLL is going to be long leg. You don't have to have that on there yet. It's just going to help us when we get to our clarification here in a moment. But when you solved here, I think some of you had square root of 5. But remember, we weren't finding the hypotenuse. You needed to subtract this one over. Can you check your work and make sure that you got square root of 3 for the length of x? Okay? So then when we did 14, if you made that mistake, you probably made it here as well. You're going to have 4 squared equals 2 squared plus x squared. Subtract your 4 from both sides. We're getting x squared is 12. To get x by itself, you have to square root both sides. And then, what does the square root of 12 reduce to? If you ladder, you're going to get 2 2s and a 3, right? So this right here should say 2 square root of 3. On number 15, we're plugging in 6 squared equals 3 squared plus x squared. Working that out, subtracting 9 from both sides. So now we have x squared equals 27. We square root both sides. We do the ladder. We're ending up with 3 3s, right, when you ladder. So we're getting that 3 to pull out front. We're getting 3 squared of 3. Okay, update your work if you have any mistakes. Okay, and on 16, you're going to have 8 squared equals 4 squared plus x squared. And on 17, you should have had 10 squared plus x squared. 10 squared equals x squared plus 5 squared. And this is what you should have gotten at their very last step when you simplified. Give me a thumbs up if you had 16 and 17 correct. Okay? I don't know about you, but I think it's pretty cool that every single time, what happened here? We were finding the long leg, and the answer reduced to the length of the short leg times the length of the long leg reduced to the length of the short leg times square root of 3. Okay? Now, if you were to use the Pythagorean theorem here, I'm going to go ahead and show you this because you are capable of seeing all of this work being done. We have x, we were writing that hypotenuse first, so we'll go ahead and do that. So 2a squared, so we already established that the hypotenuse was twice the length of the short leg, equals x squared plus a squared, right? 2a squared, we're going to square the 2, which is 4. A squared is a squared equals x squared plus a squared. We're trying to solve for x, right? So this is a 1a squared that we can subtract over. Go ahead and add this work to your paper if you didn't do this. Four minus one, is they're like terms. 4a squared minus 1a squared, we can subtract them. We're getting 3a squared equals x squared. And how do we get x by itself? Square root. So x is now by itself. The square root of 3a squared can be simplified to pull the a out front because it's a squared. The square root of a squared is a. Now the square root of 3 stays for the square root of 5. Okay. And that, again, that pattern emerged though, that every single time the length of the short leg to the long leg is times the square root of 3. And to work backwards, we will divide. And so we need to today, you don't have to have these relationships committed to memory yet. We will practice them again next class. But now we're going to practice what is the best, how do we simplify if we have, I'm going to give you like this side length is the square root of 15 as maybe one of the starters. So how do I divide by square root of 2 or divide by square root of 3 or multiply? How do we work with square roots? Okay? So go ahead and